All right, this is lesson 12.1. Chapter 12 is angles and triangles, but lesson 12.1 is what we're talking about right here. And really quickly, it says lines, hopefully you know this, in the same plane that do not intersect are called parallel lines. Example right here, two lines that would not intersect, we call those parallel. And lines that intersect at right angles are called perpendicular. So these are perpendicular lines because they cross at a right angle right there. Here's something new, though, probably to you. A line that intersects two or more lines is called a transversal. When parallel lines are cut by a transversal, several pairs of congruent angles are formed. So if I just throw two lines down there, they're not parallel, but I've got this right there. That's a transversal because it cuts two or more lines, intersects two or more lines. But when these first two lines are parallel, then we've got some congruent angles we can talk about. And the first let's name them. So we'll name this one A, B, C, D, E, F, G, and H. And now that we've got them named, it says corresponding angles. When a transversal intersects parallel lines, corresponding angles are congruent. So corresponding angles are as if I were to cut this, like maybe cut it right here, and move this intersection right down over this intersection right here. And if I did that, A would move right over E right here. So A would overlap E. B would overlap F. Okay, so, and the ones that they overlap, those are called corresponding. And of course, they are congruent, which means they're the same measure. So the measure of this angle and the measure of this angle are congruent because they are corresponding angles. Well, now, use the figure to find the measure of angles 1 and angle 2. So let's use this figure over here, and we're supposed to find the measure of angle 1 and angle 2. Well, of course, we're going to use corresponding angles. That's what we just talked about. So if I were to move this intersection right over this intersection, angle 1 would correspond with this 110 degree angle. So of course, angle 1 is 110 degrees. We can also see that angle 1 and angle 2 are supplementary, which means they add up to 180 degrees. They form this straight line right here if I put them together. So once I know that angle 1 is 110 degrees, and I know they have to add up to 180, that means angle 2 must be 70 degrees, because 110 plus 70 is how we get 180. Well, now we'll do the same thing down here to find angles 1 and 2 using this figure here. So angle 1, again, that's the corresponding angle, just like it was over here. This time, though, angle 1 corresponds with angle 63, this 63 degree angle right here. So angle 1 is 63 degrees. And for explain our reasoning, we would say corresponding angles. Angle 1 and angle 2 are supplementary. We know they add up to 180. They form this straight line right here. Since this one is 63 degrees, that would leave 117 degrees for this angle 2, which makes sense. We knew it had to be an obtuse angle, greater than 90, just by looking at it. We knew this one was acute, less than 90, so at least it's reasonable. And 63 and 117 is how we get 180. So angle 2 is 180 degrees. And the reasoning would be angle 1 and angle 2 are supplementary angles. Excellent. Using corresponding angles, use the figure to find the measure of the numbered angles. So now look at all of these angles here. They want us to find all of the angles. Well, if this is 75 degrees, and I'm going to do it over here just so we can write on it. So I've got my two parallel lines cut by a transversal, and they give us this 75-degree angle right there. Okay. Well, I know right away that this is also 75 because these are vertical angles. And remember, vertical angles, you can ignore this line right now, but vertical angles, when two lines intersect, are across from each other and they are congruent. So this is also 75 degrees. And now, using corresponding angles, this angle corresponds with this angle right here, so that would be 75 degrees. And this angle corresponds with this angle right here, so that would be 75 degrees. Those are corresponding angles. And then, because these two are supplementary, if this is 75, this must be 105. Which makes sense because this angle here is also supplementary to this angle because it forms this straight line. It's supplementary to this angle because it forms this straight line. If that's 105, this is 105, vertical angles. Yeah. And then corresponding angles here, so this would be 105. And corresponding angles here, this would be 105. And that makes sense. These are vertical, so they're the same. These are vertical, they're congruent. If you'll notice, I really only have two angle measures here. The obtuse angles are all 105. The acute angles are all 75. And we can't just write down the answers because we only have two angle measures. We can prove them by saying vertical angles or supplementary angles or corresponding angles. But we do know that when we're all done, we'll have four obtuse angles that are all the same, four acute angles that are all the same. Well, now it says, use the figure to find the measures of the numbered angles. So same kind of problem as this was. And when we're doing that, we know angle 2 will be 59 degrees, and our reasoning will be vertical angles. Angle 7 is 59 degrees, and the reason we would use is angle 2 and angle 7 are corresponding angles. Angle 5 is 59 degrees, and your choice, you could either say corresponding angles because it corresponds with this 59 degrees here, or you could say vertical angles because it's vertical to angle 7 right here. Your choice. So now we have all these 59s. And now we can do this supplementary angle. Angle 1 is supplementary to this 59 degree angle. So angle 1 will have to be 121 degrees because 121 plus 59 is 180. Angle 3 is 121, vertical angles. Angle 4 is 121 degrees because they're corresponding angles. And angle 6 is 121 degrees, vertical angles. Well, the next thing we're going to learn about is interior angles and exterior angles. So when two parallel lines are cut by a transversal, 4 interior angles are formed on the inside of the parallel lines. So 3, 4, 5, and 6, these are interior angles. And we call them interior angles because they're inside the parallel lines. 4 exterior angles are formed on the outside of the parallel lines. So 1, 2, 7, and 8 are exterior angles, and we call them exterior angles because they're outside of the parallel lines. Okay, so this says alternate interior angles and alternate exterior angles. So remember, the interior angles were these 4 angles that are inside the parallel lines. And if we're talking alternate interior, that means every other one. So let's name this, we'll just go A, B, C, and D. A and D are alternate interior. So hit one, miss one, hit one, alternate. B and C are also alternate interior angles. And this says, when a transversal intersects parallel lines, alternate interior angles are congruent. And we could tell these are going to be congruent because they're the two acute angles here. But now we have a reason we can say they are. These are alternate interior angles. B and D are also alternate interior angles, and they're congruent as well. So we can put the one line to show those are congruent, and the two lines here and the two lines here to show those are congruent. Well, the same thing with the alternate exterior angles. So we'll name these E, F, G, H. And alternate, so hit one, miss one, hit one. These two are alternate exterior angles. They'll be congruent. And these two would be alternate exterior angles. They're congruent. Okay, so then we can use this. Identify, example 4, identify alternate interior and alternate exterior angles. The photo shows a portion of an airport. Describe the relationship between each pair of angles. So 3 and 6. 3 is here. 6 is over here. These are alternate exterior. Okay, we know they're exterior because they're outside the parallel lines. And they're not next to each other. They're alternate exterior. So they're congruent. 2 and 7, they're interior angles because they're inside the parallel lines. And they're across from each other. So they're alternate interior angles. So those are congruent. In example 4, you measure angle 4 as 84 degrees. Find the measure of the angle. Explain your reasoning. So here, if this is 84 degrees, angle 3 will be supplementary to it. See how they're right next to each other? They form this straight line. So if this is 84 degrees, this must be 96 degrees. So they add up to 180. Angle 5, these are alternate interior. They're congruent because they're alternate interior. And angle 6, you could say, well, these are supplementary. And we just said this is 84 degrees because these are alternate interior. So this would have to be 96 degrees. But you could also say angle 3 and angle 6 are alternate exterior. We already said this one's 96. So double reasoning that this is 96 degrees. What you should do now is, with any kind of remaining time that you have, go to page 531 and look at the odds. When you're done working on the odds, you can go to the back of the book to check your answers and make sure you're understanding this. If you have any questions, you can comment either on the Google Classroom, or I'll be checking the comments on the YouTube video as well. So any questions that you have, you can post to either of those places. When you go to 531, also go to 532, doing the odds here as well. Excellent. And now you can go and also check out the homework, which is section 12.1 on the YouTube channel. See ya.